Okay, before we get started today with the new material, let's first take a look at a warm-up activity. So on this activity, I have 4 different equations and then 4 different graphs. I want you to match each function with its graph. So some things to think about as you're doing this is think about visually the shape of the graph. Have in your mind what a sine graph looks like, have in your mind what a cosine graph looks like. Think about the different transformations. Has the graph been shifted? Has it been moved up or down? Has it been stretched? Has it been flipped? Think about those different things as you try to do that. Remember from the other lesson, you learned how to take a graph, identify a maximum and minimum, and then write an equation from that. So that's another option as well. So see what you can do here, and then when you're ready, come back and check out the answers. So hopefully you got these as your different equations that go along with your graphs. Just a few things to point out, again, if you're having trouble just graphically seeing what's going on. I'd like to start with the first one, y equals 3 plus sine of x. We know this grows with graph B. So the only transformation that's going on here is we shifted up our graph by 3 units. So automatically you should be thinking, okay, what graph has gone up 3 units? And that should be letter B. And you know a sine graph starts and ends at an intercept, so that perfectly resonates with that one. To go to B, where it's saying y equals -3 plus cosine of x, it kind of works the same way, but this time the cosine graph moved down 3 units. And remember, it's moving down by the intercepts. So I understand that our maximum is at -2, but remember, our midline goes to our intercepts. So this shifted down 3 units, so that's how you recognize that one. Then for our last two, we know that there's been some type of shift, and then your period has changed a little bit. So that's also an indicator to help you out there. For this graph, for example, remember our cosine value starts at a maximum. So it told us it shifted us pi halves to the right, which exactly is what it did here. Okay, so today's focus is all about real-world situations and how you can model them sinusoidally. So I know that's a big word, that just means a sine or a cosine function. So let's take a look at an example. The jack on an oil well goes up and down, pumping oil out of the ground. As it does so, the distance varies sinusoidally with time. At time equals 1 second, the distance is at its maximum, 3.7 meters. At time equals 4 seconds, the distance is at its minimum, 1.5 meters. So something to point out here is you should first be thinking about what is my x and my y axis. Whenever we are dealing with a unit of time, that is our x values. So you should be asking yourself, what is my x value here? Is it seconds or meters? Well, the one that represents time is obviously our seconds. So our x-axis is all of our seconds. Then our y-axis usually represents some type of measurement. So in this case, we're talking about meters. So you should have that idea in mind. Secondly, you should see that I'm given a maximum and a minimum, which is all about what the previous lesson was, finding a maximum and a minimum value, and then creating an equation. So the first task in this problem is to sketch a graph. So when I mean sketch a graph, I mean very basically draw your maximum and draw your minimum point. So that's exactly what I did here. My maximum point is 1, 3.7, and then my minimum point is 4, 1.5. And then the only additional thing I would want you to do is to just kind of sketch a curve that goes through that here. But that's all I really mean by a sketch. You don't have to individually label each and every point, but I do want to see that max and the minimum written down. So then we get into part B, write an equation. And this literally follows suit just from the previous unit. So once I know that my max is 1, 3.7, and my minimum is 4, 1.5, I can go ahead and go through those 5 different steps for finding my equation. So again, I always start with my k value, I add my y values, and then I divide by 2. That's 2.6. Then I want to find my amplitude. I subtract my y values, divide by 2, 1.1. My period, it is 2 times my max value minus my min x value. So 1 minus 4 is a -3, but the absolute value is 3. 3 times 2 is 6. Once I have my period, I can now plug that into the peanut butter equation and get my frequency. So 6 times b equals 2 pi. I divide both sides by 6, and 2 over 6 simplified is pi over 3. And then lastly, I want to find my phase shifts. So for sine, remember, we're trying to find our spot exactly in between these two. So I have 1 plus 4 is 5. 5 divided by 2 is 2.5. So right about here is my intercept there. And then my cosine, I shift directly to my maximum value, which is 1. So now it comes time to plugging in our equation. So our amplitude is 1.1 as we're told. Notice for my sine one, it is negative. And the reason it's negative, once again, is because I'm now starting here. When I start here, am I going down first or am I going up? Because I'm going down, that means I now have to flip it, so that's why I have a negative amplitude. Then my frequency, we were told, is pi thirds. Then x, my phase shift, these are the two different ones. So it's moving 2.5 to the right, which was if it was sine, or it's shifting to 1, which was our cosine maximum value. And then last but not least, we add in our vertical shift, 2.6. So that's basically it for writing an equation for a real-world problem. Identify a min and a max, and you'll get it going. So now we have our last question. Find the distance when time is equal to 5.5 seconds. Our time is 5.5 seconds. I'm going to plug that in for my x value. So I take my two equations and I'm plugging in 5.5. Now I make a note here that you really only have to pick one equations to plug it in. The reality is if you plug it in both of the equations, that kind of helps you check your answer because you have to get to the same value. So if you don't get to the same value when you plug it in both times, you did something wrong. So it's kind of a good check. So here we go. I'm plugging in 5.5 for my x value, so that's why I now got rid of x and I plugged in 5.5. So we'll do it first with the sine way, and then we'll look at the cosine way and make sure that we get the same answer. So my first step is to always start by subtracting my parentheses. We're kind of following a little PEMDAS here. So 5.5 minus 2.5 is now 3. Now we want to think about this as our angle. So altogether, this pi thirds times 3, that's actually representative of our angle. So what is pi thirds times 3? Well, that's just pi. So now I want to take the sine of pi, because now that I figured all this, I simplify this area right here. The sine of pi is 0, and you get that by looking at your unit circle. So now I have 0 times negative 1.1, which is just 0. I add 2.6, so my final answer is 2.6 meters. Now let's go ahead and try that out with our cosine one to make sure we got the same thing over here. So again, I start with my parentheses. 5.5 minus 1 is 4.5. Now I multiply 4.5 by this pi 3, so that's where I get down here. I evaluate the cosine of 4.5 pi over 3. Now obviously, that's not exactly evaluating a unit circle, so you can plug it into your calculator. When you do plug it into your calculator, make sure you are in radians, because you have a pi symbol. Anyway, the value of cosine of 4.5 pi over 3 is 0, so again, you get 2.6 meters. So that's how you do a problem like that. So let's get a little bit more practice with these. I made them so you can just use your unit circle. You don't need to use a calculator at all, because I want you to kind of get in the habit of really utilizing that unit circle, knowing what each thing represents. So here's my two questions for you. Given y equals 24 cosine of pi over 3 times x minus 2 plus 13, what is the distance traveled in miles after t equals 3 hours? Given y equals 14 sine of pi over 6, x minus 3, plus 12, what is the height of the wave at 8 o'clock a.m.? So go ahead, plug those in for x, and figure out what your answers are. So hopefully you got the following. You got 25 miles, and then you got 19 feet. So go ahead and look through that work to make sure that you are on the same track. So now I would like you to try. I have a worksheet here that gives you a few extra problems, and then please go ahead and check the key on Classroom as well to make sure you don't have any questions. Please make sure you are being very careful as you identify your max and your min value, because if you don't get your max and your min values correct, then you will mess up the entire problem. So please go ahead and complete that now.